algebraic techniques to evaluate limits and infinity, I will go over examples related to polynomial, exponential function, and trigonometric function. The first one is a polynomial divided by another polynomial. So in this case scenario, you have to find out the biggest exponent in the denominator, so which is a third power, right? So and then you will have to divide each term by x raised to that power, which is 3. So we will divide each term by x to the third power. Do we care about the biggest power in the numerator? The answer is no. We only care what's in the denominator. Can we, instead of a 3, can we do a 4, a 5, or a 6? The answer is no. If you go above 3, you will have a 0 in the denominator. If you go below a 3, you will have an infinity in the denominator. So there is no other choice other than 3. If the highest degree, do you see the 3 in circle? If that is a 10, then we will divide each term by x raised to the 10. If that is a 69, then we will divide each term by x raised to the 69th power. Alright, so let's do the division. So moving on to the next step, I will write the equal and then limit as x approaches to infinity. We have 2x divided by x to the third minus 8 divided by x to the third, 5x to the third divided by itself. Denominator, we have x squared divided by x to the third plus 3x to the third divided by x to the third minus x divided by x to the third, and then we work on the numbers for the exponent. So the first one is 2x squared 8 over x to the third plus minus 5, and then divided by 1 over x plus 3, and then minus 1 over x squared. So once x goes to infinity, all the little fractions become zeros because you have a 2 or 8 divided by a huge value. So 2 divided by 6 million, 8 divided by 6 million, they are just a 0. So we have a 0 minus 0 minus 5, and then a 0 plus 3 minus 0. So we have negative 5 divided by 3. So for this function, y equals to negative 5 over 3 is a horizontal asymptote as x approaches to positive infinity. So you look all the way to the right hand side, y equals to negative 5 over 3 is a horizontal asymptote. Okay, so that is the first case, polynomial. And then the second case, I have exponential function. So for exponential function, there is plenty to talk about in this example. So this one, we do not need to divide each term by 2 raised to the x. So this one, I will just rewrite the exponential function first. So this one, I will write limit as x approaches to infinity. The 2x plus 1 is just a 5 raised to the 2x times 5 raised to the first. Same base, right? You multiply them, you add the exponents. And then the denominator, that is 2 to the x, and then times 2 to the third power. And then we rewrite one more time. So that is a limit as x approaches to infinity. So that is 5 squared. You square first, and then you do the x power. This is a 5. And then a 2 to the x. 2 times 2 times 2. 4 times 2 is 8. Alright, and then what is next? So they both raise to the x degree. So what we are going to write next is, so that is equals to limit as x approaches to infinity. Break that down into 2 fractions. So this is 25, right? And then divided by 2, they both raise to the x power. You can do that, right? And then times 5 over 8. Okay, now, when you have a 25 divided by 2 raised to the x power, raised to infinity. So that means just don't think about fraction. How about 20 raised to infinity power? You have a number, any number, 20, 30, 35, 60, 100, I don't care. You have a number, let's say 60. You raise that to infinity power. So that means you are taking 60 multiplied by itself, or taking a number multiplied by itself infinitely many times. What is the product going to be? The product is going to be infinity, right? So that is equals to infinity times 5 over 8, so that is equals to infinity. And in some cases, they would like you to point out that the limit does not exist. But there is a plenty to talk about in the 25 over 2 raised to the x. So this is a 25 over 2. If they ask you to provide a reason, is greater than 1. Pick a value, any value, any number greater than 1. Multiply that value by itself many times to see what do you get. You will get infinity, right? So since that is greater than 1, then 25 over 2 raised to the infinity power, that is equals to infinity. I know you want to ask me this, hey, what if I have 2 over 25? So what if I have 2 over 25, not 5, 25, but you get the same thing if you get use a 5, to the infinity power. So what is that equal to? Since 2 over 25 is between 1 and negative 1, then 2 over 25 power raised to the infinity, that is approximately equals to 0. So here is the picture. So we have a 0 and then a negative 1 and a 1. So you pick any number between them, between negative 1 and 1. Pick any number right here between them. You raise that to infinity power, you will get a 0. So if that number is outside of this interval, then you will get an infinity. So you can think about this, 0.25 raised to the infinity, so that is approximately 0. Negative 0.25 raised to infinity, that is approximately equals to 0 as well. But if you consider outside of the interval, like 2 raised to the infinity, that approaches to infinity, or negative 6 raised to infinity, that goes to infinity. This one depending on how many times. If the power is even, then you get a positive. If the power is odd, then you get a negative. All right. Okay, so we talk about exponential function. Let's do one more exponential function. That one you kind of have to draw a graph and then draw an analysis other than just showing a bunch of algebra. Okay, so that one is a limit as x approaches to infinity. I have 2x times e to the negative x. What is that equal to? So first of all, that is limit as x approaches to infinity. 2x, we bring the negative exponent down to the denominator to eliminate the positive. So as x goes to infinity, you have looks like you have infinity over infinity. But I already said that infinity over infinity or 0 over 0, they cannot be determined. Then what do we do? In this case, do we agree that the e to the x is an exponential function? The 2 to the x is linear, right? The exponential function grows so much faster compared to the linear function. If you just look at a graph without doing any numbers, then this is e, right? So this is e. So this is e to the x, but the 2 to the x is a linear function that kind of looks like this. So this is a 2 times x. So the exponential function grows so much faster. So when x is equals to a 2, so this is only a 4, right? But this is 2.7 raised to the second power. So the exponential function is way bigger compared to the linear function. So let's say when x is equals to 10, and then the 2.7, or which is e, raised to the 10 is so much bigger than 2 times 10, right? So this exponential function grows faster. And then this one grows slower. So that's why when x is at infinity, you have an astronomical value in the denominator. So you have a large value divided by a huge value. As a result, that approaches to 0 because the denominator is so much bigger when x is very large. So overall, that is equals to 0. Okay, moving on. Let's pick a different color. Let's pick yellow. Last one. So we have limit as x approaches to infinity, how about a trigonometric function? X to the negative 3 times cosine of x. So that is equals to limit as x approaches to infinity. We have cosine of x divided by x to the third, right? So at infinity, what is cosine? If you are looking at the graph of cosine, the cosine looks like this. Starts at 1, right? Bouncing between 1 and negative 1. Bouncing between 1 and negative 1. And x to the third is large, right? So cosine x is bouncing between negative 1 and 1. As x goes to infinity, you can't really determine because y oscillates between negative 1 and 1. But how about x to the third? So if you have an infinity raised to the third power, that is equals to a huge infinity. So overall, what you have is you have something between negative 1 and 1 divided by a huge infinity. Whatever this value is, it's just some values between negative 1 and 1. You divide it by infinity. So overall, that is equals to 0. Alright, so that is the end of this video. If you like it, you think this is helpful, give me a like, share, and subscribe. And I will catch you all in the next one. Signing out.